distinguished ambassadors, Dr. Lim Tin Meng, Chief Executive of Science Center Singapore, representative of the Singaporean government and the scientific community, friends of the Chilean Embassy, good evening from Singapore, good morning from Chile, and good afternoon, Europe. We have attendance from all over the world following us today. Welcome to the Chilean Astronomy, A Window to the Universe, an event organized in partnership between the Chilean Embassy in Singapore and the Science Center Singapore. My name is Andrés Borlone. I am the Deputy Head of Mission of the Embassy of Chile in Singapore, and it's my pleasure to guide you in this journey where you will have the chance to explore the wonder of outer space through the eyes of the Chilean astronomy. This event is part of UNTAME Festival, REBOOTING Our World. We would like to inform you, everyone, that the online event is up and running with an on-site carnival upcoming. Also, if you would like to attend the following day's event in person, you can still get your tickets. All links will be in the description below. Before starting, please allow me to share the screening rules. We would like to remind you that this webinar is being recorded. About how to pose questions, we have two ways. For the people here with us this evening, just raise your hand. From the ones who are following us from YouTube, please click on the Google form link in the description below and type your question anytime you want. Question will be answered during the Q&A session. For any additional question, or if you would like to contact us, you can do it through the email address in the description. I would like to have a special thanks to Science Center, in particular, Dr. Lim Tin Meng. Doctor, we are really grateful for the collaboration received from your team. Now, let me introduce Ms. Carolina Valdivia. She is the Undersecretary of the Ministry of Foreign Affairs for her welcoming remarks.
Dr. Lim Tin Meng, Chief Executive of the Science Center Singapore, distinguished ambassadors and representatives of the scientific community, ladies and gentlemen, esteemed friends across the Pacific. Greetings from Chile, a tricontinental country which is committed to fostering cooperation with like-minded partners, especially Singapore, where knowledge achieved through various scientific initiatives is key in order to bring about sustainable development, the advancement of technology aimed at contributing to the welfare of our ever more globalized citizens and communities, and a much deeper understanding of our surroundings, our planet, pristine forests, oceans, Antarctica, the universe, and all else to be thoroughly explored, as curiosity is a hallmark of the human experience. My words to you at this inauguration ceremony of Chile, A Window to the Universe, an initiative co-organized by our embassy headed by Ambassador Ignacio Concha and Science Center Singapore, come about at a time when, as published a few hours ago by Science magazine, we have a rough sketch of what the next decade could bring in astronomy and astrophysics, given that the U.S. National Academies of Science, Engineering, and Medicine released a decadal survey laying out scientific priorities and funding recommendations for the next 10 years of astronomy and astrophysics research. The document, called Pathways to Discovery in Astronomy and Astrophysics in the 2020s, identifies three top-line items that the disciplines should concentrate on: the discovery and study of habitable exoplanets, the exploration of black holes and neutron stars as a window to the early universe, and a better understanding of the origin and evolution of galaxies. It also stresses the importance of making astronomy a more inclusive and diverse field. The decadal survey also recommends making key investments in huge ground-based telescopes, especially the giant Magellan telescope, which is currently being built high in the Chilean Andes. It has been in the last few decades that Chile has proven to be a prime spot for astronomical observation, a status that has been a boom in many ways for our country. Northern Chile's Atacama's desert could easily be mistaken for the surface of another world. Sparse rainfalls make the Atacama one of the most arid regions on Earth, giving it barren conditions you would expect to find on Mars. the Atacama stretched for hundreds of miles between a high coastline in the west and the Andes Mountains in the east. Because of its unique location, the desert has clear skies more than 90% of nights during the year, with barely any water vapor in the atmosphere. When you put it all together, you get these unique conditions that explain why the Atacama is the best place in the world to put telescopes. The Large Synoptic Survey Telescope, the LSST, the European Extremely Large Telescope, the EELT, and the Giant Magellan Telescope, the GMT, are all complete, up and running. Chile will be home to around 70% of the total astronomical resources in the world. Work conducted at Chilean observatories has contributed to major scientific advances, such as the 1998 discovery that the universe is expanding at an accelerating pace, an insight that led to the study of dark energy, along with the recent first-ever image of a black hole. It's really hard for me to think of a single astronomical milestone in the last 20 to 30 years that didn't involve observatories in Chile. Astronomy has developed at a very fast rate, and it's now on Chile's impeccable night skies has drawn interest from the international scientific community for more than a century. It is worthwhile to note that the study of astronomy as a discipline in Chile can be traced as far back as the 18th century, when astronomers from the United States and Europe set out on scientific expeditions to our country and helped establish a handful of local astronomical observatories. In the middle of the 20th century, when Adelina Gutiérrez became the first Chilean woman to obtain a doctoral degree in astronomy, the University of Chile and the U.S. National Science Foundation joined forces with the Association for University for Research in Astronomy to establish the Cerro Tololo Inter-American Observatory. This complex of astronomical telescopes and instruments, built in the mountains that skirt the southern edge of the Atacama near La Serena, became Chile's first large international observatory. Shortly after, the European Southern Observatory built La Silla Observatory, one of the several sites it now operates in the country. Since then, a highly recognized community of renowned astronomers have been working in our country with various Chilean universities, offering master's and PhD programs, consolidating Chile as a world-class leader when it comes to exploring the universe. The success of this development is not only due to the excellent climate and geographical conditions found in Chile, but also due to the forward-looking policies and the coordination amongst professionals representing different institutions, such as the Ministry of Science, the National Agency for Innovation and Development, universities, and the academia. Chile actively promotes investigation in science, in technology, engineering, and mathematics, focused on girls and women. During this week, a roundtable session will be dedicated exclusively to this important topic, where Chilean leaders will share their own experiences in STEM and initiatives to promote inclusivity, equity, and diversity in astronomy. Chile established a gender equality policy in science, technology, knowledge, and innovation. This policy includes a 50-50 by 2030 action plan, which will implement more than 30 steps, such as the establishment of a scientific research programs for young students and funds to support institutional plans for universities aimed to close their gaps in gender in research. In this regard, I would like to highlight that just a few days ago, the World Academy of Science recognized a young Chilean astronomer, Laura Pérez, for her significant contributions to reveal the signatures of planet formations using innovative high-resolution imaging to study protoplanetary disks. I would also like to highlight the contributions of the Chilean Ministry of Foreign Affairs towards furthering national and international astronomy. Support for science has become part of one of the pillars of Chile's foreign policy work. Today, Chile seeks to position itself as a hub for innovation, offering unique development spaces for foreign researchers and institutions under the auspices of cooperation within a national scientific ecosystem. Dr. Lim, distinguished guests, friends, Chile and Singapore are APEC member economies. Our bilateral relations have entered a new era of cooperation aimed at joining efforts in order to face the multiple challenges facing an ever greater interconnected world. Among the stepping blocks of our strategic collaboration, the signing of the Digital Economy Agreement and Singapore's upcoming access as a full member of the Pacific Alliance certainly do stand out. We would also note that green hydrogen is poised to be the clean energy that will power the world, while digital trade is the future of the economy. Singapore and Chile have taken significant steps to be partners in both of these directions, and we are enthusiastic regarding the contributions we can achieve at a time when the world needs tangible solutions to address issues such as the climate emergency, pandemics, renewable energy, efficient and secure trade. I am sure that you will agree that when it comes to Chile and Singapore, the opportunities are boundless. In this spirit, the Chile, A Window to the Universe, is an invitation for Singaporeans to considering pursuing a career in astronomy as well as in those science and engineering specialties which beckon all of us to contribute to transform the way we see the world, how we understand the universe, where we aim to go in the future, with Chile as part of the equation. I truly hope that all Singaporeans will enjoy this unique event. Thank you very much.
Thanks, Undersecretary. Indeed, Chile's natural advantages and robust institutional framework have contributed to Chile's success in astronomy. Now, I'm pleased to welcome Dr. Lim Tim Meng, Chief Executive of Science Center Singapore and Associate Professor at NUS. Professor, the floor is yours.
Okay, thank you, Andres. And just pardon me, I had to look down onto my script and look up at you at the same time. Her Excellency, Mrs. Carolina Valdivia Torres, Vice Minister, Ministry of Foreign Affairs of Chile. His Excellency, Mr. Ignacio Concha, Ambassador of Chile to Singapore. Distinguished ambassadors, distinguished guests, friends and colleagues, ladies and gentlemen, a very good evening to everyone here and a very good morning to everyone in Chile. Thank you for coming. It is my honor and privilege to welcome all of you here to the opening event of Chilean Astronomy, A Window to the Universe. This inaugural event opens a 4-day transmedia astronomical experience, which is the first of its kind in the history of Science Center Singapore. This is also part of this year's UNTAME Festival 2021, and we are very grateful to the Chilean Embassy for the strong support and this significant partnership. UNTAME Festival is our flagship program in Singapore, championed by Science Center Singapore, for celebrating everything about science, technology, engineering, mathematics, arts, and humanities. We want people to open their mind to appreciate in our everyday, everywhere, anytime, anywhere, the beauty of science and how scientific knowledge and innovation advance our civilization for a better tomorrow. And earlier you heard Her Excellency for her very eloquent speech about importance of STEM. One of the most intriguing science subjects undoubtedly is astronomy. As little boys and little girls, we used to sing the song, "Twinkle, twinkle, little stars, how I wonder what you are." Even when we grew up to become older boys and older girls, the fascination of the stars above us, the night sky, in the cosmos, remain a deep interest and mystery to us. And thanks to astronomy, to astronomers, scientists and engineers, space science innovation and instrumentation, we can literally open a window to the universe. This 4-day event will feature many outstanding astronomers and scientists from Chile. And also, we get to see and experience the world's largest astronomical project, the ALMA, the Atacama Large Millimeter Submillimeter Array. The rich contents and programs during these 4 days will certainly be both educational and inspirational. As we look out into the skies above us, we should all be reminded that we are one people sharing this one planet together. This collaboration and partnership between the Chilean Embassy and Science Center Singapore is therefore of significance as a platform to bridge cultural understanding, promote knowledge exchange, and foster friendship and partnership across the globe. Just think about it. No matter how far apart we are, compared to the universe, compared to the cosmos, we are actually very close neighbors. I'd therefore like to end by expressing our sincere thanks to His Excellency, Mr. Ignacio Concha, Ambassador of Chile to Singapore. I remember we talked about this almost a year ago, and today it is real, it's happening. And also want to thank the Chilean government, and especially Her Excellency Mrs. Carolina Valdivia Torres, Vice Minister of Foreign Affairs of Chile. Thank you for your partnership, thank you for your friendship, thank you for your support. And I also want to thank all of you for your presence here this evening. I wish this inaugural Chilean astronomy event in Singapore a great success, and may we all enjoy a fascinating evening together. Thank you very much.
Thank you, Doctor, for your words. The contribution of the Science Center Singapore to the diffusion of the scientific interest and knowledge is invaluable. Please join me to welcome His Excellency Ignacio Concha, the Ambassador of Chile to Singapore, to deliver his welcome speech address.
Thank you, Andre. For everyone, good afternoon in Singapore, buenos días to people in Santiago de Chile and other cities in Chile. You know, we are now under the southern hemisphere skies. So it's quite a surprising event tonight, seeing the skies. Professor Lim, Chief Executive, Science Center Board, His Excellency Carolina Valdivia, Vice Minister of Foreign Affairs of Chile, dear panelists, distinguished colleagues, ambassadors, ladies and gentlemen, dear friends. The Embassy of Chile in Singapore is extremely proud of organizing Chilean Astronomy, a Window to the Universe seminar. Hosted by the Science Center Singapore, along with the enthusiastic participation and support of a great team of expert public servants, filmmakers, observatories, and astronomers in 3 different continents for the joy of the people of Singapore. To all of them, my deepest acknowledgements. And I must tell you, this is the first time that Singapore and my country join forces to showcase the marvels of the Chilean skies for the observation of the universe's secrets. For centuries, humankind has asked itself who we are, why we live in this earth, or are we alone in the solar system? Perhaps the answer to this and other questions related not only to the origins of the universe, but also humankind, can be solved by the modern astronomers that scrutinize the skies from the north of Chile. That is indeed a big challenge, but they are up to it. Modern astronomers are like the 15th century navigators. They embark in their small and fragile naus or ships to discover new continents, people, or even oceans like the Pacific. Just an example of how relevant for the world the astronomical observation is, in the proximity of Las Campanas Observatory, the giant Magellan telescope is being built. This telescope will have a resolution 10 times higher than the Hubble Space Telescope. The giant Magellan telescope will start operating very soon, 2024. Together with the extremely large telescope in Chile as well, it will be the most powerful telescope on the planet. It promises the greatest revolution in astronomy since Galileo Galilei. By the end of this year, Singapore will become an associated member of state of the Pacific Alliance. Singapore's accession to the alliance represents a milestone for its country members and their policy towards Asia-Pacific region. It is also a challenge that invites us to seek for new engagements, perspective, or cooperation areas. No doubts that astronomy, where Chile clearly has a comparative edge, could contribute to strengthening of cooperation ties between both countries, Chile and Singapore. We also see this event as part of the activities and seminars organized in Singapore to commemorate the 10th anniversary of the foundation of the Pacific Alliance. I come from a seemingly remote country, but plenty of natural resources. The best way to put them to good use is inviting other countries to be our partners. It is for this reason that we are committed to explore with Singapore new avenues such as digital trade, clean energies, or robotics. We also attach high importance to cooperate with Singapore in science and innovation as a springboard to the future. Thank you all for being here tonight with us. And we invite you all to continue looking to the future through the glass of a telescope. Thank you very much. And please, Professor Tim, come forward because I have a gift for you. Thank you again. Thank you very much. Close to my heart. Thank you.
Thank you, Ambassador, for highlighting the importance of Science Center and technology in Singapore-Chile bilateral relations. Now, let me introduce Dr. Maria Argudo Fernandez. Dr. Argudo Fernandez is the president of the Chilean Astronomical Society, so CHIAS. She will enrich us with the presentation, the development of astronomy in Chile and the natural laboratory in the Chilean desert. Doctor, the floor is yours.
Everyone, can you see me? Can you see my screen?
We can hear you perfectly.
Perfect. Okay. So, thank you everyone. Good afternoon. Everyone. Thank you very much for this invitation to here and to share with you the exhibition for this week for Chile a window to the universe. At the beginning, of this presentation, I don't know. Yeah, it's working. As In the introduction, I'm the president of the Chilean Astronomical Society, and I'm going to talk about the conditions in Chile for astronomy, and talk about a bit of the community and the people there that are contributing to science. At the end of this presentation, I prepare a video. I don't know if I'm going to run it or another one is going to run so you can see better. That's fine to present this video now. If not, I can try to live.
The sky, the stars, and space have always attracted humankind. Since the early ages, we have felt curiosity for the unknown, asking ourselves what is beyond, what is farther away. We would like to answer questions like, what is our origin? What is the universe? What are the stars? Is there life in other worlds? The curiosity and interest to learn about the universe has awakened in Chile and the rest of the world. Many citizens have become professionals, dedicating their lives to reveal what lies beyond our planet and adventure in discovering the mysteries of the cosmos.
In Chile, this interest started more than 150 years ago, when the National Astronomical Observatory was founded. Due to the extraordinary vision of its director in the late 50s, astronomy was boosted in the country and is participating in the most interesting discoveries of the universe. Dr. Adelina Gutiérrez was the first Chilean to obtain a PhD in astronomy, an awesome example, being a woman. Since then, an internationally highly recognized community of astronomers has been established in the country, with more than 20 universities offering master and PhD programs. Our country is consolidating as the best place in the world to explore the universe.
Although stars lie far away, in Chile, they can be explored and admired by everyone. Professional, outreach, and inclusive programs are shaping a future in which all talents can contribute to the development of astronomy, which has grown exponentially in the last decades. Ground-based telescopes are becoming larger and larger. In space, new telescopes and missions are exploring the universe. We are ready to look through new eyes and contribute to the constant development of science.
In recent years, we have made great progress in the study of the universe. To me, the most exciting ones are the confirmation of the existence of black holes, the acceleration of the expansion of the universe, the discovery of extrasolar planets, and that stars and planets are born together in clouds of gas containing complex organic molecules. All the discoveries have been possible thanks to the great advances in new technologies to build complex and state-of-the-art instruments, and the talent and creativity of many astronomers, engineers, and technicians behind those projects.
Everywhere in the universe, a new discovery will be revealed, and most of these discoveries will be made from our country. By 2030, 70% of the astronomical capabilities will be operating from Chile.
Our technical and scientific teams will be actively participating in this endeavor, constructing new receivers for ALMA telescope, developing complex control system for multi-object optical spectrographs, building lighter and more durable mirrors, and mastering big data and machine learning algorithm in the LSST broker for real-time reduction, analysis, and alerts of petabytes data management. This is millions of gigabytes, to name a few.
Our clear and dark skies, the most advanced technologies, and the quality of our professionals and scientists will be key in many investigations about the origin and evolution of the universe.
Our skies are an example of a successful natural laboratory. Not just clear skies are required. You also need leadership, collaboration, and commitment from the country.
Because exploring is imprinted in humanity, we wish to continue investigating the infinite space, our firmament, contributing to science and knowledge every day, promoting new talents. Our national anthem says, "How pure Chile is your blue sky." A sky that is waiting to show us the unrevealed and mysterious secrets of the universe. Chile, place of science and discovery.
This is Dr. Monica Rubio. She is the former president of the Chilean Astronomical Society, and she is the actual National Science Award of Chile. It's the highest prize and recognition for scientists in Chile. We are very, very happy for her. I will continue with this presentation, and then I'm going to explain how something happened with my screen. Sorry. Okay, now you can see. Okay. So it is called that Chile is a natural laboratory for astronomy, and people you already know, has been produced the conditions in Chile for astronomy. So I'm going to share these screens from the space, from the NASA picture. And so you can see the north of Chile from space. So from the space, you can gain a new perspective from our planet. So what you see here is the desert, but I would like to call your attention. So here is the ocean, and the other side is the Andes Mountains. But what can call your attention is that here a lot of clouds at the other side of the Andes. In the Pacific Ocean, it's full with clouds as well, and then there are no clouds here. This is because of a phenomenon called the Humboldt current. So then the conditions in the Atacama Desert, it's not only the high altitude, but the cold and dry. It's a perfect condition for a very stable atmosphere that allows the high quality astronomical professional observations. So what you can find there is this kind of environment with clear skies and many potential sites to enjoy the vision of the universe. So this is a natural laboratory with, that allows to all the three key properties for good astronomical observation. But the third one is the quiet skies, and this is the only of the three vision that it only depends on us. We need to always have a proper care with the flora, the fauna, and the area without light pollution. So we have a good support from the country to work on this matter. Then Chile, with its exceptionally clear and appropriate sky for high altitude astronomy, along with a stable legal framework for the administration to facilitate projects to arise, settle and do science in collaboration with the Chilean scientific community, which is what I'm going to talk a little bit. CIAS, the Chilean Astronomical Society, the Chilean National Committee for the International Astronomical Union, and represents the interests of the professional Chilean astronomical community. This is a non-profit scientific society founded in 2000. And I'm going to talk a bit about the main objectives of the SOCIA. So one of the main goals is the development and dissemination of astronomy in Chile to facilitate and stimulate research and teaching of astronomy in Chile, organize scientific meetings and specialized courses and conferences on astronomy and related science. What you see in the back image is a picture of a national meeting between the Chilean Astronomical Society and the Argentinian Astronomical Society. So this is where we had in-person meetings. We hope to have one soon. Here is Monica Rubio. Yes, very well. Also, the goals are to maintain contacts with the organization and companies, not only in Chile, but international partners, and to facilitate the study of astronomy and related science and their teaching by professionals. There are actually about 24 institutions in Chile that have active research in astronomy. As you can see, here is the map of Chile. You can see that it's very, very large. This is the pointing of the different regions in Chile where there are astronomers and in universities. Half of them are concentrated in the central region, metropolitan region in Santiago, and the other half are distributed along the country. It's a very large country with more than 4,000 kilometers from north to south. The northest city is Arica, and the one in the south, going to the Antarctica, it's Punta Arenas. Then it's not a surprise that we had 3 different total solar eclipses in 3 years, since we have a latitude difference of about 40 degrees to south. So the first one in 2019 was in the totality in the area of the region of Coquimbo. The second in the south, between this area in Los Rios and in the of Araucanía, the region of Araucanía, and the third one is going to be this year, is going to be seen in the Antarctica. So all professionals working in astronomical institutions have access to the facilities that are in the north of Chile, diverse regions. In the Atacama Desert that is shared by 3 different regions: the region of Antofagasta, the region of Atacama, and the region of Coquimbo. So the most advanced telescopes in the world are located in this area. Among them are Paraná, the European Observatory, the ALMA Radio Astronomy Telescope, Cerro Tololo, and SOAR and Gemini South that are in the region of Coquimbo, Las Campanas Observatory from Cambridge Institution, also Coquimbo, and another facilities in the Atacama Astronomical Park, which is in the region of Antofagasta, the Vera Rubin Observatory, and also has participation, the Chilean Astronomical community. It's a full partner of the Sloan Digital Sky Survey 5 collaboration. So we are trying to not only coordinate the effort from all the community, but also we take care to create a welcome and warm environment within all the astronomical community, both from the protection of the skies with the SOCIA's working group of the light pollution and the SOCIA's working group for gender and inclusion. So the community is very diverse in the regions, but it's also very diverse in research topics. Well, before going to there, I want to highlight this very beautiful picture of the first of the 3 total eclipse in Chile from the Observatory of La Silla. Yeah, so as I was saying, this is a very diverse community with a variety of research topics covering all the scales from superstellar objects to galaxies. So there are some astronomers focused on understand the life cycles of stars from how they born and die and all the cycles, and also interesting on study different stars because not all the stars are the same or similar to our sun. They are variable stars. Many stars are born with a sister, so they are binary stars. To study the disk that form around protostars and how planets fall there. This is a new field on astronomy of planets, exoplanets. These are planets that are orbiting another stars farther, very far from our sun. Also to study other objects in our solar system as planets and asteroids, or how stars are bound together forming stars clusters and globular clusters, and how globular clusters and stars bound together forming galaxies, studying our galaxies and other galaxies in the universe, how the galaxies form and evolve, and studying the large scale structure of our universe. Not only on science, but some groups also are focused on the development of instrumentation and new techniques for astronomy. I'm going to highlight a few of them. There are instrumentation laboratories along all the country as well, focused on radio astronomy with the development of new receivers for ALMA, for instance, also in the optical and the infrared range with the development of new mirrors or advances in adaptive optics for telescopes. And also there are some other groups working on science, on data science, using clusters to work with data or to run numerical simulations. Regarding technological development, I'm going also to highlight some of the recent advances. As I was saying before, and also Monica in her video, there is a collaboration between the University of Chile with the development of the Band 1 receiver for ALMA. This is a new receiver and had the first light very recently in September 2021. Also, the LSST has been selected. It's a Chilean collaboration and will be the broker for the Vera Rubin Observatory. I would like to say that the Vera Rubin Observatory is the first observatory with the name of a woman, Vera Rubin, who is the mother of dark matter. This is a reduction pipeline to work in real-time observations based on artificial intelligence to classify events from observations. Also in the nucleo of planetary formation in the University of Valparaiso, they are creating and developing lighter and more durable mirror segments that can build together to create larger telescopes with a better quality. So you all know about the future. I guess that this is probably during this week is going to be named a lot the new telescopes and observatories that are going or are planned to be located in Chile as well. So by right now, you know that if we consider all the telescopes larger than 4 meters in diameter, considering the optical and infrared-based ground-based telescope, Chile has the total collecting area of light is around 40%, but by 2030, it's expected to concentrate 70%. Actually, that maybe you have know about this number a lot, but I would like to give a little more information. So this is considering, as I say, telescope larger than 4 meters in diameter, but if we consider telescope larger than 10 or maybe larger than 20, Chile is going to have the 100% of these telescopes. So I would like to better say that Chile is having and is going to have the most advanced space ground telescopes in the entire world. So, three of these main observatories are the giant Magellan telescope, and this one in the picture, the Vera Rubin Observatory, as I said before, and the ELT is the Extreme Large Telescope, this one, also located in the Antofagasta region. So this is my presentation. Thank you very much for your attention, and I hope you have enjoyed all these pictures as me. Thank you very much.
Dear Maria, thank you for your presentation. It's wonderful to understand what a natural laboratory is and the path that Chile has followed to become an astronomic hub. So thank you so much for your presentation. And following our program today, let me present the documentary Big Astronomy, People, Places, Discoveries. This documentary explored 3 observatories located in extreme environments and remote locations in Chile. The show is narrated by Bárbara Rojas Ayala, a Chilean astronomer. The film is the winner of the Best Astronomy Education and the Best Science Film Award. Hope you enjoy the show.
As an astronomer, I always marvel at the night sky. It's beautiful, of course, but light from the universe also helps us unlock its secrets. My name is Bárbara Rojas Ayala, and I study stars. We have learned that almost every star we see hosts 1 or more planets, and we're finding more planets all the time. So for me, the night sky is filled not with distant, lonely stars, but with countless families of planets. I want to share some of these family stories with you, where they come from, how they take shape. But I also want to introduce you to where I come from. A place where astronomers study the sky, with the help of amazing technology and even more amazing people. A place where people have experienced a strong connection to the night sky for millennia. I want to introduce you to astronomy in Chile. Chile lies on the west coast of South America, a long, narrow, mountainous country. The Pacific Ocean lies to the west, the towering Andes Mountains to the east, and the Amazon rainforest to the north. Chile is perhaps the best place in the world for observational astronomy because of its special climate. The Andes block rain clouds from the east, while currents in the Pacific Ocean bring cold waters north from the Antarctic. Along the Chilean coast, the air temperature drops, and as the cool air sinks, it loses its moisture. These factors combine to create stable dry air over Chile's coastal mountains with few clouds, perfect conditions for astronomy. Many major telescopes dot Chile's mountainous terrain. We will visit just 3. These observatories are looking at places in our solar system and beyond to help astronomers understand where planets like ours come from. Standing on the side of this mountain, you can understand why it was named Cerro Tololo, which in the Aymara language means at the edge of the abyss. Cerro Tololo Inter-American Observatory is home to dozens of telescopes. Let's take a look at the largest, the Victor M. Blanco telescope, with a primary mirror 4 meters in diameter. Astronomers designed this telescope to observe the same kind of light our eyes can see. It's an optical telescope. Light enters the large opening and bounces off the giant mirror. It's the first thing the light hits, so we call it the primary mirror. The bigger the mirror, the more light it can collect. So astronomers like to build large telescopes to gather as much light as possible. The shape of the mirror focuses light on a giant lens, more than a meter across. That lens is part of an amazing instrument called the Dark Energy Camera.
The Dark Energy Camera has 62 science detectors. It's one of the biggest cameras in usage in the world right now.
Marco Bonatti is the first of several people we'll meet who keep these observatories running. As an electronics detector engineer, he's responsible for what happens inside the instrument.
You need to be very careful that they are clean all the time, because otherwise you have all sorts of stuff deposited in the surface, and the surface is especially coated. Basically, we want to avoid any dust particles. So in the clean room, we have a controlled environment. We can control the amount of dust inside by basically you having filters and positive pressure that keep the dust out. All the light that the telescope gathers goes to a single point, basically. At this point, you put a detector. So the detector you put there depends on the science you want to do and the instrument, a lot of factors.
Once the instrument is out of the clean room and mounted on the telescope, other team members help make the observations.
My name is Jacqueline Cerón, and I work at Cerro Tololo Inter-American Observatory. My position is night assistant. This means taking care of the instrument and having the telescope ready, taking calibrations, and making sure that everything is working fine. And during the night, operating the telescope, which means moving the telescope to the position that the observer wants, and making sure that everything is working correctly. What I really like is to learn in general how the telescope works, how it takes data, and all these different systems that are interconnected and that, accomplish such a huge task, and all the engineering involved. It's amazing.
Let's hear more from Kathy Vivas, a Venezuelan astronomer living in Chile.
I am part of the support team of one instrument in the Blanco telescope, the Dark Energy Camera, which is a wonderful instrument. It's special to make surveys to cover large portions of the sky. As part of the support team, we make sure that the camera is producing science quality data that is ready for astronomers from all around the world to come and do their science projects with the telescope, and that they can achieve their science goals with this instrument.
The Dark Energy Camera was designed to peer into the farthest reaches of the universe. But because it can observe a large portion of the sky, it also helps us search for objects much closer to home. Leaving Earth behind, we see the orbits of planets around the Sun. Mercury, Venus, Earth, and Mars. Jupiter, Saturn, Uranus, and Neptune. But our solar system includes many other objects, not just planets. Astronomers have used the Dark Energy Camera to find numerous small, icy bodies in the outer reaches of the solar system. We have tracked thousands of these objects, which reside far away from the Sun, past the most distant planet, Neptune. They make up what's called the Kuiper belt. Billions of years ago, everything we see here likely revolved in the same plane. But the massive planet's gravity tugged the lightweight Kuiper belt objects into different orbits. They now travel far above and below the plane of the planet's orbits. Each tiny icy world we discover helps us answer questions about the history of our solar system. What did it look like billions of years ago when the planets were taking shape? We can't go back in time, but we can observe other planetary systems in the process of forming. This work requires our most powerful telescopes, so let's return to Chile. We're heading to a mountain called Cerro Pachón. Only about 20 kilometers from Cerro Tololo. Here we find the Gemini South Observatory, which began viewing the sky in 2002. Inside the dome, we can see the giant telescope with a mirror more than 8 meters across, more than twice the diameter of the Blanco telescope. This giant mirror must remain highly reflective, which means it needs cleaning every week. Such a big job requires a lot of teamwork.
My name is Vanessa Montes. I'm an electronics engineer. We have different disciplines like optics, mechanics, electrical, software also. We all work very well, and it's a lot of team effort and a lot of collaboration between everyone. And I think that that's very positive. The more you can encourage people to participate more creatively in the different projects that we do, it's a more collaborative work environment.
Cooperation on Gemini extends around the globe. Astronomers rarely travel to Chile to use the telescope. Instead, they telecommute. Here, in the Gemini base facility in the coastal town of La Serena, nearly 100 kilometers from Cerro Pachón, technicians can operate a special instrument that looks at young planetary systems, called the Gemini Planet Imager, or GPI. Almost 10,000 kilometers away, at Stanford University in California, observers see the same displays and guide the work with GPI. Astronomers need somebody they can trust on the other end of the line, and that's where Alicia Shugart, Science Operations Specialist, comes in.
We operate the telescope at night. We take data for the astronomers who have all contributed proposals for science. I really enjoy observing. I think about it as if these photons that literally are billions of years old are arriving and I'm seeing them for the first time.
Not all photons are billions of years old. Many were created more recently, closer to home. Light detected by GPI reveals what happens when planets form around nearby stars. We can imagine traveling to one such place, so far away that its light takes more than 60 years to reach us. This star is more massive and much brighter than the Sun. The star and its planetary system are less than 30 million years old, mere infants compared to our own middle-aged solar system. Dust and debris form a disk around the star. Some tiny objects in this disk will end up like our Kuiper belt, icy bodies at the edge of the system. GPI allows us to peer into the center of the disk. Astronomers then use computers and the laws of physics to simulate what might be happening. We have discovered one giant planet, more than a dozen times more massive than Jupiter, whose gravity has sculpted the dusty disk into a warped spiral. Could something similar have happened in our solar system billions of years ago? For the next part of the story, we must now travel much farther north in Chile, to the Atacama Desert, one of the driest places on Earth. Home to a collection of 66 radio antennas, the Atacama Large Millimeter Submillimeter Array, or ALMA. The skies of the Atacama Desert are famously clear, and people have observed the sky from here for millennia. David Barrera is president of the indigenous community of San Pedro de Atacama.
I feel that the cosmos walks with me. It walks with you, with humanity. It is part of our life. We humans are nothing compared to what the great cosmos is. That is why we are part of the cosmos. We walk together. We make up a single unit. That is the marvel of the human understanding. ALMA has been a respectful neighbor because it has asked what is the ancient wisdom of the native people in regard to the cosmos. And ALMA's invitation to the indigenous community is in some way to unite scientific knowledge with indigenous knowledge.
Astronomers have come to this unique spot on Earth to build an array of telescope antennas that benefit from the clear, dry skies 5,000 meters above sea level. These giant antennas work together. like a single enormous eye observing the sky in unprecedented detail. And they can work both night and day. Each dish weighs about 100 tons. And they need to move from place to place, both to make different kinds of observations and to receive maintenance when needed. Alfredo Elgueta is one of only 4 people trusted to operate the transporters that move the telescopes.
The transporter has just one basic work that is designed to do, and it's move this big radio telescope from one point to another. When you're doing the maneuver of trying to load the antenna or unload the antenna, you have to do it with the remote. But when you're doing the translation from one point to another, you have to do it from the cabin. So every time that an antenna needs like a big fixing or anything, we try to bring it down, but it takes a lot of coordination to do that. It takes around 5 hours, driving 5 kilometers per hour.
Once the antennas are in their correct locations, they collect a huge amount of data, and they work as a network. Data from each antenna is compared to data from every other one. Celia Verdugo, an astronomer and data analyst, collects and studies these observations for astronomers from Chile and other parts of the world.
The kind of light we are collecting from the sky is a light that is emitting in radio wave shape, you see. We are looking at the parts of the universe with the lowest temperature, and because of that low temperature, they emit their energy through radio waves. We collect that signal, and from that, we can get either spectral information, or we can also get images of the source we are observing. And we are taking data for projects that are breaking the limits of what we know, going beyond the limit of our knowledge. That is really fascinating, yeah.
One of the ways ALMA has revolutionized our view of the universe is by giving us a close-up look at young planetary systems. Here, we are seeing not just the leftovers of planet formation, but the actual disk of material from which planets take shape. This is ALMA's image of PDS 70, a very young star, less than 10 million years old. Its debris disk looks more like a ring of dust surrounding the star, with a large gap where at least one Jupiter-sized planet is forming. That planet has a small disk of its own, where moons could be forming around it. Here, we're seeing the results of a computer simulation, which we can compare with data from ALMA and other telescopes to help astronomers understand how planets grow. Perhaps our solar system looked like this billions of years ago, a family of planets taking shape. Pioneering work in astronomy requires investing in the next generation of telescopes. When completed, this telescope will observe the entire visible sky every few nights. It will generate 20 terabytes of data each night, twice as much as the Hubble Space Telescope generates in a whole year. All the data will be made freely available to the world, enabling anybody to make the next great discovery. The future of astronomy lies in all our hands. That's why I enjoy meeting with the students of all ages. I hope some of them will grow up to work with me at one of Chile's great observatories or elsewhere in the world. All of us you met today come from different backgrounds with many different talents and skills to contribute. We invite everybody to look, to learn, and to enjoy astronomy. We hope to share the wonder of the sky and the excitement of discovery with the whole world. If you'd like to meet more amazing people and hear more stories about big astronomy in Chile, visit bigastronomy.org, where you will find live conversations with observatory staff, exclusive behind-the-scenes content, and educational activities.
After this incredible film, I am pleased to introduce Dr. Shannon Schmoll, Director of the Abraham Planetarium at Michigan State University, representing Big Astronomy Project. She will give us details about this ambitious endeavor. Shannon, the floor is yours.
For having me. I'm going to start by talking a little bit more about the Big Astronomy Project. So what you just saw, the planetarium show, is just one piece of this project. And this is something that we really wanted to try to extend how people can engage with the content beyond the show itself within the planetarium show itself within the planetarium. And so we went in trying to support people in different ways of learning. And we also wanted to have a lot of different opportunities for people to meet more of the folks who work at the observatories. And so I know that this is also a Q&A session, so I'll just start talking, and if you want to interrupt me for any, we'll be a little flexible here. Okay, so I kind of want to go back a little bit to another program called the Astronomy in Chile Educator Ambassadors Program, or ACEP for short. And this is a program that takes US-based astronomy educators and has also taken Chilean-based educators around Chile to some of the observatories you just saw in the show, with the idea that we can experience it firsthand and come back and help talk to people about why we build so many telescopes in Chile and why is it such an important place for astronomy. And so I was part of the 2015 cohort along with two of the other folks, Renee Kerrigan and Vivian White, who are on the Big Astronomy Project. And we also have Tiffany Stone-Wolbrecht, who is part of the 2018 cohort that went down. And so it's gone down every year since 2015, and it's a really wonderful program. But after experiencing that, we really wanted to share that with the world. And planetariums are really fantastic environments because we can immerse people in different places. And so we could take people to Chile like you just saw on the show. And in a planetarium, it's fantastic to do that. It makes you feel like you're there. So just like you learned in the show, astronomy takes big teams of people in order to make things happen. It is also true for a project like this. So we are funded by the National Science Foundation in the US, and so all the telescopes featured are funded by NSF in the show. So we didn't have time to visit all of them, but we focused on those that NSF funds. So we also have California Academy of Sciences who produced that show. They went and filmed in 360-degree film in order to show everyone and take everyone and transport them to Chile through the planetarium. We have the Ward Beecher Planetarium, which is helping with distribution of the show and managing the web portal, which you'll hear more about in a minute. The Peoria Riverfront Museum is managing live events. So we're doing events sort of like this around astronomy in Chile we've been doing them. We've done about 36 of them, I think now, and we still have about 15 to 20 more that we plan on doing. Astronomy Society of the Pacific created hands-on kits for this program. And so there's hands-on kits that have gone out to planetariums and museums with extra activities. And for me at the Abrams Planetarium at Michigan State University, we have a team there that is managing research around how people engage with the content beyond the planetarium. And also now, due to the pandemic, we're comparing online versus in person. And then AUI and AURA are the organizations that manage some of the US-based telescopes in Chile, and they're sort of managing all the different aspects and connecting us with all the various folks who work at the observatories that you saw featured. So ultimately, the show has several learning goals, and hopefully you learned from them from seeing that show. So one is multi-wavelength astronomy. We wanted to emphasize that there's different types of light that we study within astronomy, and that gives us different clues beyond what we can see with our eyes. We wanted to emphasize that what astronomers need for great observing conditions, and that Chile is one of the best places in the world to do that. And one of the big things that we really wanted to do with this project is show that everyone can participate. We really wanted to show people, have people see themselves as someone who can participate in astronomy, and that there's a lot of different avenues to do that. It's not just a research scientist at a university. There's definitely a lot of great work that goes into that, but we also need engineers. We need drivers of those big transporters. That's everyone's favorite. We need people to take care of the mirrors. We need chefs in order to make sure that there's food there for everyone to eat. And so we wanted to show that you could have an interest in astronomy in a lot of different ways and still participate. And then we also wanted to show that astronomy is rooted in different cultures of the world. We wanted to share indigenous astronomy within Chile as well. And so to do that and to support people in continuing to learn, help them in exploring what they are most interested in, giving them that choice, we have the planetarium show, but we also have the hands-on activity kit. We have a web portal where you can go access more behind-the-scenes content, more videos, additional content. And then we have social media, so that includes Facebook, Instagram, Twitter, and YouTube, where we are doing live events where we have longer interviews with some of the people you saw in the show, as well as people we interviewed for the show but didn't make it into the final version, as well as other people. And we wanted to be able to show people as whole people. They're not just scientists, they're not just people who work in science, but they have bands, they have families, they have hobbies, and that's a way to help people see themselves represented in who's in the show as well. So you just saw the show. You saw that it was narrated by Barbara Rojas Ayala, who is a Chilean astronomer who studies exoplanets. We did this in both Spanish and English, so she did the narration in both, and everyone you saw interviewed also were interviewed in both Spanish and English. And so we have two versions of the show. We have a German version that's I think complete, and we're also working on other translations. We don't need to see the trailer. Okay. We also have this toolkit, so a little bit more on that. There's a lot of different activities. This one is sort of astronomy is for everyone, so this features different astronomers and different people who work at the observatories, and they're categorized by what type of work that they do there, so educators, staff, astronomers, and engineers. This is one of the activities. Here's more. We have one on light pollution. So this you can take this mag light. It has a candle mode, so you can stand it up, and then you put this little shield over it to show how you can shield light and contribute to better dark skies. We have something that explores different filters we might use on the sky, something that shows you what how the sky might look different depending on the light pollution. This glows in the dark. We have stories from different cultures related to different constellations and star knowledge. And then this is an umbrella. You can only see a corner of it, but this is a model of the galaxy, of the Milky Way, on an umbrella that you pop open so that you can talk about the shape of the galaxy and show where people are within it. We all love those umbrellas. They're fantastic. We also have the web portal, so I thought I would show that. So here you can learn more about what's going on. So these live events that we do on social media, you can come check out when the next one will be. You can see the different images here. You can learn more about ASAP. This is where you can request the full dome planetarium show, but we also have a flat screen version of it that is now available for classroom teachers. So if this is something you want to show to your classes or in a different educational environment, but you don't have a planetarium, there is a different way to show it as well. So you can request that here. We have links to all the activities as well as that bonus content that I was showing. So there's virtual tours here, more images that you can go check out. And then we also have our research. So we are, this is more information on our research. This is our team. And you can see what our current published articles are on the research that we are doing. And back to here. We also are on social media. So like I said, we're doing these different social media events that are interviews with different folks who work at the observatories. And so those are all done on Facebook. But after we are done on Facebook, they get uploaded to our YouTube channel here. So you can see the trailers for the show. We have videos in both English and Spanish. Real People, Big Astronomy is sort of our series that we've been doing, talking to different people who work at the observatories with different jobs. We've also done Big Astronomy Live, so we've featured the different telescopes and learned more about them, and then more interviews of people that didn't feature in the show, but we did interview. So you can go check all of this out on YouTube. We're on Twitter and Instagram, so you can find us on all 4 of these places as Big Astronomy. And right now, we don't have any events planned currently, but we will be having at least a couple more by the end of the year. So if you follow us, you'll be able to hear more about when those happen. And if you missed them on Facebook, you can always come back to YouTube. We also finally have an educator guide. So this includes a description of the show, activities you can do in the classroom, and it also has more information on Atacamino constellations and star lore. And so this is another great activity for anyone who's an educator, both informal and formal. So I think maybe I'll stop here and see if there's any questions, and if not, I can talk more about all more specifics here. So, and I see, yeah.
Thank you, Doctor. Indeed, we have a few questions, but some of them you have already answered. And
okay.
But we still have more questions. It's a great effort that the Big Astronomy Project to make astronomy more accessible to people all over the world is remarkable. And indeed, what you mentioned about that astronomy is more than, it goes beyond to the scientific community. Behind that, there are families, there are a big community of people. Actually, in Chile, in ALMA, the 85% of the people who work in ALMA are local contracts. So this is a very interesting thing that is happening. And we have now the Q&A session, so I will remind you that you can write down your questions on the Google form if you are following from YouTube, or just raise your hand if you are here with us. And let's start with the first question. It's from Andrea. The question is, how do astronomers discover planets around other stars?
So that's a great question. There's a few different methods that we use to study them. One of the earliest ones that was really successful was the transit method. So if you look at a star, as the planet goes around, if it's at the right angle, as the planet goes in front of the star, it'll dim the star a little bit. It'll block out some of the light. So if you see that happening with a regular period, you can infer that it's a planet, and you, depending on how long and how big that dip is, you can start understanding more about the planet itself. There's the radial velocity method. So this works really well for really big, close planets. So for the most part, planets go around a star, and the center of mass between those two is inside the star, so it just looks like it goes around. But if you have a large enough planet, that center of mass is actually outside the center of the star, and so that means the star wobbles a little bit. So you can see that wobble happening. So when you look at the spectra of the star or the light of the star, you actually see shifts in the light when it's coming toward us and away from us. And so you can detect that wobble. We're also starting to with telescopes, like the GPI imager on the Gemini telescope has helped us actually see things more directly because it has such a high resolution. So we're starting to use that, but the big ones are still transit and radial velocity.
Thank you so much. We have another question from Belinda. Belinda, how can the telescope work day and night? How can telescope work day and night?
So optical telescopes can only work at night. So these are the ones that use the same light that we see. So we need those ones to only work at night. But radio telescopes, that light can come through our atmosphere. We don't need it to be dark. That's still coming through our atmosphere. It's not being blocked out by the sun. And so the radio telescopes like ALMA, those can work day and night. It's just the optical ones that have to work at night.
Thank you. And how can Singaporean students follow and participate in the activity that Big Astronomy organizes?
So the best thing would be to follow us on social media or go bookmark the bigastronomy.org, which is our website, and check out when we have these different events that are happening. You can come and join on there. There's also, oh, sorry, I'm hearing some feedback. It's also on Zoom as well, and so so you can join by Zoom if you don't have Facebook. Sorry, is everyone else hearing that feedback, or is it?
Now one more philosophical question. Why should humans, maybe you or Dr. Argudo Fernandez can also answer, both of you can answer this question. Why should humans be interested in the universe? What kind of answer to our daily life can we get?
I can start, I guess. I think that's a really interesting question and an important one. I think what studying the universe really can offer us is we push our limits as humans. We don't know what we're capable of and what we want to study until we're trying to look at things that are so far away. And in that process, we learn new science, we learn new information that we can then apply here that we would have never really thought about until we pushed ourselves to look at. And I also always go back to Carl Sagan's quote of we are a way for the universe to know ourselves. We have a curiosity to understand our place in the universe. And so studying the universe helps us understand that and appreciate. I hope it makes us appreciate just how lucky we are to be here in order to even think about the world. So I think there's a very practical and very philosophical answer there.
Another question. The documentary mentioned that you look at low temperature areas. Should a newly formed solar system be warm?
They're still very hot. They're just cooler than everything else around them. And so there's going to be different temperatures. I don't know if Dr. Maria would like to try to answer that a little bit better. But
Dr. Maria, she has a little problem, connection problem, though she's coming back soon.
Okay.
I'm not able to answer this question, so does anyone have any question, please? Raise your hand.
Thanks, Dr. Schmoll. I would like to know, since we've seen in the documentary that many scientists from all over the world are benefiting from these telescopes. So I would like to know, I'm curious to know which countries are partnering or collaborating with these telescopes in Chile and of course with the US you mentioned. Thank you very much.
Mm-hmm. So there's several different I'm most familiar with the US-based ones. But there's the US, there are Chile is always a collaborator. For ALMA, for instance, Japan is a major collaborator. There's also the European Southern Observatory, ESO, which is a big collaborator on ALMA, which includes a lot of different European countries. And so those are some of the ones that are featured within the show, and I'm sure that there's more countries that collaborate with some of the other observatories as well. But every one of these things requires a large collaboration, be it different universities within a single country or multiple space agencies across different countries, because it takes a lot of funding to make this happen. And then when we do this, it benefits everybody in the end. So those are some of the collaborators that are featured within the telescopes within our show.
Is there any other question from the people here? Otherwise, here we have another one. Thank you.
Hi. I have a question. I realize that there are a lot of women in this project, and I was wondering if that's a coincidence. I love to see women in in science subjects. So are there more women than men, would you say, studying or working in astronomy, or is it just a coincidence that you have more women in this project? Yeah, thank you.
I don't know what the exact breakdown is. I think in astronomy we tend to have a more even distribution of men and women. And we did feature a lot of women in the show. We wanted to make sure that we did feature a lot of women in the show because there's certainly fewer women in science in general, and so we wanted to make sure that we highlighted all the different ways that people can participate, both men and women. So our project definitely has quite a few women. We wanted to feature that. I think on the whole, astronomy is fairly even. Especially sort of in the undergraduate level, as you go higher, it maybe isn't quite as even, but it's I think compared to a lot of sciences, we are sort of about 50-50. At least in the US. I don't.
We have another question from Adrian from Singapore. Is it difficult to find a new planet?
It's getting easier. It used to be very difficult, but we're getting really good at it. So there's some really great videos you can go check out that show how we're discovering exoplanets around other stars, and it sort of starts off very slow, and then in about the past 10 years, it starts exploding because we're getting really good. We're getting better telescopes that can look at smaller differences in light that we have. They're a lot more sensitive. So yeah, it's getting easier. It's still not the easiest, but we're getting there.
Dr. Argudo Fernandez, welcome back. I know that you have a problem. We are here in the Q&A session, so if you want to share something with us about the question that we have asked, please, the floor is yours. Now, we had before a very philosophical question about why should humans be interested in the universe, and what kind of answer to our daily life can we get? I'm sorry to insist in this one, but we have to answer to this student.
Which one? The recent question about the planets?
It's a question about what kind of answer to our daily life we can get watching the universe.
I didn't listen to the question very well.
So the question is, why should humans be interested in the universe? Is there any more general explanation about what we are looking for in the universe?
I think that it's normal curiosity. Humans are curious by nature. So I think that one of the first questions that humans have, and maybe the beginning of the philosophy is why are we here? So we try to answer this. So why are we here? We are trying to find the hints of that to answer that question. Now we know that we are made of stars. The death of stars create new components, and those components are in our body, are in our bones, are in our skin, in the food we eat. So I think that we are answering that. Why are we here? What are all the processes that bring us here? How life was created in our planet? What are the conditions? It's assume of a lot of conditions that bring us here. Not only so, it's not trivial that there is life in this planet. We need the other planets to care of us. So, for instance, now we know that because of the gravitational influence of Jupiter is having all the asteroids that prevent to hit our planet. Also, the moon, it's our shield. Also, the sun, it's our shield in its movement along the galaxy. So we are answering all these questions, and we hope answer that. Maybe if we can find life in other planets, that will also help us to understand life here. But I think that it's curiosity that brings us to give this step.
Exactly, and this curiosity had been in the history of humanity for years. As someone mentioned during the documentary, the indigenous people in Chile have watched the universe for centuries, and as well in other civilizations. In Mexico, we have here this 9 ambassador of Mexico. So it's a very something that has been present in the humanity for a long time. Thank you, Dr. Argudo Fernandez. We have another question from Sofia from Singapore. Will our telescope be able to see the Big Bang? Dr. Schmoll?
That's a very difficult question and also very interesting because we cannot see, well, for now we only can see with our telescope, we can see only light. If there is no light, there is no way we can understand what happened there. The further light that we can see is the remnant of this Big Bang, that is the cosmic microwave background. But now we have a new window to the universe because of the gravitational wave detector. So we don't need only light right now, but still we cannot go there. We cannot know what happened there. We can maybe elaborate some theories of what happened there by studying the light and now microwave wavelengths, but we don't know yet. So we cannot see the Big Bang. We can see the remnant of the light, but for now, I don't see that we can see it. Maybe Shannon wants to add something to this answer.
Yeah, the only thing I would add is kind of expanding on that multi-messenger idea. So I think a really big thing within astronomy now is we have only ever used light, and now we get to we have something totally different that's not light with gravitational waves. And so we're calling that multi-messenger because it's not just light coming to us, it's this gravitational waves. And so I think and that's kind of brand new in a way. It's like just started to happen that we've been able to detect them. So I think it's going to be really exciting to see how that develops.
Any other question here in the Science Center?
Thank you. It's very educational and very exciting to see, and I must commend you for hosting this show. I really enjoyed it very much. Just one minor question. Now with the advancement of technology, do you see your telescopes being redundant in 100 years' time? Thank you.
I can take a stab. I don't think any of the telescopes are going to really be redundant. Like in some ways, some of them do look at the same wavelengths of light or something like that, but there's a lot of questions to answer. There's a lot of astronomers who have projects that they want to try to understand the world. Every time we ask a question and try to answer it within science, we get more questions. And so having the telescopes available and ones that have slightly different capabilities is always going to be useful because it gives us more opportunities to answer those questions.
Yeah, I would add to. Sorry, I will add to that we have a lot of telescopes, but all telescopes are different. Not all telescopes are the same, and they all contribute to answer questions, and they complement very well. So you can have similar telescopes, but also the instrument that you use to investigate the light that they receive, it's different. So they all complement, and they are all necessary.
Now we have the last question. This is from Singapore, from Sin N. How do I start a career in astronomy?
That's a big question because there's a lot of different ways. So that's what we were trying to show within Big Astronomy is that there's a lot of different ways to be involved in astronomy. So I would start by asking like, what are your interests? What do you care about? See if there's a local astronomy club that you can join where you can start kind of answering that question about yourself. And there's different majors that can go into astronomy. So you can study physics and astronomy, go to graduate school and do research, and that's certainly a very common path within astronomy. But maybe you are more interested in the engineering and the instruments that are built, and so you might go down a more engineering path. So I would say start by finding a local club, learning all you can, see what you're interested in, and then look at the types of jobs that you're interested in, and then see what they're requiring. So you're not applying yet, but you can go check out what you are interested in. But there's a lot of ways to get involved, both as an amateur astronomer and a professional. So see what you like.
Thank you, Dr. Schmoll. Well, thank you all of you to be here. Thank you, Dr. Argudo Fernandez. This is the end of the session. We will continue tomorrow at 4 p.m. at this very same place with the broadcast of the documentary, The Eyes of the World. This film explains why Chile attracts so much astronomical interest, who is behind this scientific development, and the implication this change have for a country's science development. Please do not forget that you can attend the following day's event in person, getting your tickets in the description below, or follow by streaming at the link that appears on the screen. Thank you and good evening.